So if you've ever built your own custom reactive operators, you've probably had those moments. You know, the ones where you're just staring at your screen, scratching your head, because things are just not behaving the way you expect? Well, today we're going to pull back the curtain on a super important, kinda under-the-hood utility that is the absolute key to building powerful, stable, and predictable operators. We're talking about the operate function.
Okay, so here's our game plan. We're going to start with a problem I'm sure you felt before, the runaway subscription. Then, we'll introduce Operate as the hero of our story. We'll break down how to configure it, talk about the amazing subscriber chain it creates, and then see exactly how that chain solves our runaway problem. And finally, we'll zoom out and talk about why this little utility is a huge deal for any developer working with Reactive Streams.
All right, first things first. Let's really dig into a problem that can be an absolute nightmare to debug: the runaway subscription.
You know the scenario, right? You've got your logic all set up, you slap on an operator like take one, and you expect it to do exactly what it says, take one value and then complete. But it doesn't. It just keeps going and going and going, completely ignoring you. It feels like your car's brakes just went out and you're sitting there yelling, "Why won't this thing just stop?"
And what's really cool is that the documentation actually has a perfect name for this: the synchronous fire hose scenario. This happens when an inner observable starts blasting out values so fast, like a fire hose, that your teardown logic from downstream just can't get set up in time to turn it off. It's a classic frustrating race condition.
And this right here is why we're talking today. Let's introduce the tool that was purpose-built to solve this exact problem, the Operate utility. So what is Operate? At its heart, you can think of it like a factory. Its one main job is to be the official, recommended way to create your own custom operators for observables. I mean, it's the same foundational block that the library itself uses to build its own operators. And here is its secret weapon. This is the crucial guarantee it gives you. Operate makes sure that the entire subscription chain, all the wiring from start to finish, is completely connected before a single piece of your subscription logic actually runs. Just by doing that, it completely wipes out the possibility of that fire hose race condition ever happening.
So how does it actually pull this off? Well, let's pop the hood and look at the configuration object you give it, which is called the operate config interface. It's actually really simple. This config object just needs two main things from you. First, a destination, which is basically the next subscriber in the line, and second, your subscriber overrides, which is just where you put the custom logic for your new operator. Think about their roles like this. The destination answers the question, where does the value go next? It's the downstream subscriber waiting for the notification. Your subscriber overrides, on the other hand, answer the question, what do I do with the value right here? It's a special logic for this one specific step before you pass the value along.
And it's this relationship, this connection between the destination and your custom logic that lets Operate build its most powerful feature, the subscriber chain. The key word here is chaining. When you call Operate, it doesn't just make a new subscriber. It actually links or chains that new subscriber to the destination you provided. I love this analogy. It's like plugging a bunch of extension cords together. Each operator adds another cord to the chain, making sure you have one continuous connection all the way from the power source to your lamp. So let's trace the path. 1, Operate creates a new subscriber. 2, it immediately chains it to the destination. 3, values start to flow, passing through your custom logic on their way to that destination. And 4, this is the magic bullet, when the very end of the line gets unsubscribed, that signal automatically zips backwards up the chain, unsubscribing every single link along the way. And that cascading unsubscribe, well, that brings us right back to our original problem. This is the big aha moment. Let's connect the dots and see exactly how this chain puts out that fire hose. So, just to recap the problem one last time, the fire hose happens because values start flowing before we have a path to send an unsubscribe signal all the way back to the source.
And the beautiful, elegant solution built right into the architecture by Operate is the subscriber chain. It's the very mechanism designed to stop this from happening.
So here's the play-by-play. Because Operate guarantees that a complete teardown path is built before anything starts, when our take one operator finally gets its one value, it can confidently call unsubscribe. That signal hits the end of the line and immediately cascades up that chain we built, link by link, all the way back to the source, shutting it off instantly. Problem solved. No more fire hose.
So, okay, this is great. It fixes this one specific, really tricky bug. But what's the bigger picture here? Why should you really care about understanding this utility? It all boils down to this. Operate isn't just some random helper function. It's the foundational tool for writing your own well-behaved operators. It gives you an ironclad guarantee that your subscriptions are wired up correctly every single time. And that is the absolute bedrock of building a stable, predictable, and robust reactive system. And really, this is what's so exciting. Now that you have the key, the tool for crafting your own custom operators that are just as safe and reliable as the ones in the core library, the question changes. It's not just about fixing bugs anymore. It's about creation. So what powerful new operator will you build now?